Welcome to Unscripted Coding. Today we are going to do a LeetCode problem together. Now it's been a while, so I'm choosing medium difficulty, and hopefully we can walk through it together without too much difficulty. So I'm going to pick one at random here. Looks like some of these are behind a paywall now, but we'll find one here. So we'll work on problem 2177. Find three consecutive integers that sum to a given number. Over here we have, given an integer num, return three consecutive integers as a sorted array that sum to num. If num cannot be expressed as a sum of three consecutive integers, return an empty array. So we have num equals 33. That's 10 plus 11 plus 12. So there are some numbers that wouldn't work. So for example, 4. If you add 0, 1, 2, you get 3. If you go 1, 2, and 3, you get 6. So there are no solutions for that. There are constraints. It has to be basically a positive number. I think it can be equal to 0, and they just put an arbitrarily large number in there. I think this one is surprisingly simple. Maybe I'm just more of a math person than an algorithm person, because I don't think there is much of a process here. You have an integer, so it is a fixed solid number, not a decimal, not a fraction. And the only way this can be true, three consecutive integers, is if it is divisible by 3. So for example, they gave the example 33. It's divisible by 3, which means 11, and then on either side you are just adding or subtracting 1 from that integer. So for example, if you wanted 3 divided by 3 is 1, and then you want on either side because they compensate for each other. So 1 minus 1 would be 0, and 1 plus 1 is 2. So you get 0, 1, 2. And you could do this with anything. Go with 6, you're going to add 1, 2, and 3. Go with 9, you're going to have 2 plus 3 plus 4. Yes, that's right. And I think that should work no matter how large your number gets. So I'm going to create the solution with that assumption. We could, if this doesn't work, we could potentially create a test, I suppose. But for now, let's try this. The number is called num. So we will take num, let's go middle is equal to num divided by 3. Oh, no, let's do the test first. If num divided by 3 equals, no, we're going to use modulo so that we can see what the remainder is. If there is 0 remainder, if you remember the math without fractions and decimals, you get remainder. So 10 divided by 3 is 3 remainder 1. Modulo will give you a remainder if it doesn't divide evenly. So our test is if there's no remainder, that means it can be properly divided. And we'll have this middle number, and then we'll have the else statement here. I hope that is correct. Okay. And then else, if it doesn't divide evenly, we return this empty piece. So I'm going to put output equals this, return output, so it's an empty list. Now, if not, we will have first equals, nope. Let's not do that. Middle is num divided by 3, and we know that's evenly divided. First is going to be middle minus 1. And last is going to be middle plus 1. And then we will have output equals first, middle, and last. And I don't think we need the else statement, actually. We just return output. And I think that should do it. So let's run it and see how that works. Uh-oh. Indentation didn't match. What happened here? Does not match outer indent level. Let's try running it again. Feel like I must be doing something very, very stupid here. Maybe I need brackets? Okay. Let's try and run it on Code Sculptor, see what it says here. Solution equals solution. Solution dot sum of 3, and we are going to give a number 33. And then we'll print answer and see how far we get here. See, seems to work just fine. Oh, I should go int on each of them. Int. Let's see if I remove this test, what happens. Okay, if, and we'll just recreate this, num modulo 3 equals 0, return, no, output equals 1, 1, 1. And let's run this, see how that looks. Okay, and then we'll just do this all over again. Middle is num divided by 3. First is middle minus 1. Last is middle plus 1. And I am going to drill this in because you guys are seeing this over and over. Int and middle. And we'll go int and last. And there we go. Let's submit and see how far we get. There you go. Perfect. That seemed to have worked. That was kind of disappointing, but I guess we did take 8 minutes to try and solve this properly. Let me know if that was helpful. I don't think that was the most exciting solution in the world, but it is yet another problem you want to think through. So thanks for watching. I will see you again very soon.